but it's named after the guy who figured out that this constant exists. It equals approximately 2.718, and it continues indefinitely. So it is an irrational number like pi, where it doesn't stop. So like this, like pi goes on forever infinitely, Euler's number will go on forever infinitely as well. So what you need to know is that E equals about 2.718, and it is a constant. Okay, so it's just like a number. It shows up in different places in real life. So what it shows up is when we're trying to model continuous growth. So like we talked about compound interest, right? Compound interest formula when something is being compounded every month or every year or twice a year. But if it is being compounded continuously, that's where we would use E, that this number shows up in that computation. So we'll see it in growth and decay functions such as radioactive decay, continuously compounded interest, the natural log is a log with a base of E. So it is written differently.
Well, I thought it was 10.
Oh, no, that's the common log. Common log has a base of 10. Natural log, so this is log base 10. Natural log is log base E, which we write as ln, natural log. Okay, so I usually do it in cursive. You can do it with just a lowercase l. I just feel like sometimes it looks like a 1, so I like to make the cursive so that it's clear that I'm writing natural log. So natural log of x is the same as log base E of x, except we do not use this notation. We always write it as the natural log. So when you see this, you need to know if you are moving to exponential form that the base is E that you then take to a power. Yes. Okay. If we were going to write this as a log, what we would technically do, logarithms always have to have the word log. This is technically log with a base of E of 9. Answer to a log is the exponent. However, we are not going to write log base E. Instead, we should write what? ln. So we get rid of log base E, and we write this as natural log of 9 equals x. If we're going to go from log form to exponent form, what is the base of number 2?
Number 2?
Yeah.
That would be x.
Nope, what's your base?
ln.
E. Remember, the base of the natural log is always E. So we'd take E to the E power equals x. That would be our exponent form of the log. Number 4, how would you rewrite this in log form? What? ln x equals 4. Because what we would start with is a log with a base of E, which becomes the natural log. And finally, number 4, if we rewrote an exponent form, our base is what? E to the x equals 25. If you have a natural log and you need to expand or condense or simplify, the same rules apply. So if we were going to condense this, the only difference is that instead of having log, we're going to have ln. Okay? So remember, where does this 6 go and this 2 go when we condense? Yeah, this goes, okay, both of you are right, but we're going in 2 orders. First, the 6 is going to go be an exponent of the 8. So this will be ln 8 to the 6th minus ln 4 squared. And then, because it is subtraction, we're going to rewrite the argument as division. Natural log of 8 to the 6th over 4 squared. This is going back to our exponents. We want to get these to have the same base so that we can get this completely simplified. So how could we rewrite 8? What should our same base be of both of these? 2. Let's rewrite 8 as 2 to the 3rd, right? To the 6th. And 4 would be 2 squared to the 2nd. What do we do with these exponents?
We subtract them.
Well, first, what do we do with these two? Yeah, we're going to multiply those. So we get 2 to the 18th over 2 to the 4th, which becomes what? Now we subtract 18 minus 4.
14.
So we've got natural log 2 to the 14th. Okay? Good. And we're going to leave it like this because they want it in this condensed form. If we were going to expand it, we'd put the 14 back out. But so you always are trying to simplify as much as possible. All right. Okay, so move the exponent, then you do your multiplication, and then you simplify everything out. Okay, number 3, first step, move this exponent here. So we get natural log 3 squared plus natural log 4 plus natural log y. Okay, all of these are addition, meaning what are we going to do with all of the argument? Multiply. Natural log of 3 squared times 4 times y. So we put it all into one argument and then simplify. Natural log 3 squared is 9 times 4 is 36 y. And that is our most condensed version.